for the end, but we need to move on now. And our next speaker is Rosa Martinez Álvarez-Castellanos. I don't know if I pronounce it correctly, but we're very happy to have you here. She's a research and development technician at the Marine Technology Center at CTN, and this is an association of marine and maritime companies in Murcia, Spain. So she has a telecommunication engineering master degree from the Polytechnical University of Cartagena, and also through the AQUAEXCEL2020 project, she has been accessing the same facilities, I understand, as ASCO has explained earlier, but well, from a Spanish angle this time. So very welcome you to the talk, which will be on improving Atlantic salmon feeding process efficiency with a smart system for feeding control. So we're moving on to the feed issue now. So
yes, thank you very much, Alexandra. I'm going to try to share my screen. Just 1 second. Okay, I think you can see it now.
Yes, yes, perfect.
Yeah, perfect. Indeed, it is a really long name, but it's well pronounced. Well, thank you everyone for inviting us to this session. Indeed, I'm going to guide you through the insight of our project, improving salmon feeding process with the smart system for feeding control. As Alexandra said, I work as a research and development technician at CTN, which is a non-profit association that works to different sectors of the naval and industry and marine industry, transferring research and innovation to the companies. So in this sense, CTN promotes the strength of business, professionals and public administrations to increase the competitiveness of the sectors. For this, we cover a wide range of areas which are boosted by a series of skills and capabilities that includes IoT, web technologies, data science, machine learning and deep learning algorithms, and so on. But going into the scope of this webinar, a few years ago, we delved into the agriculture sector with a national project, and we realized that one of the main concerns of this sector was the feeding control. Because of the high production cost it involves, the significant amount of food that is wasted, and the increase in the environmental impact that this produces, both in the environment and in the surrounding of the fish. And through an exhaustive research, we also find out that most of the technologies used will also imply high costs, excessive monitoring time, and a lack of accuracy. So we realized that a solution to solve this lack of control should be able to optimize the feeding process in a sustainable way and taking into account this economic viability. And of course, the technology that would solve this lack of control should be autonomous, in real time, and cost efficient. That is where the SICA, the Smart System for Feeding Control in Spanish, came into the picture. The SICA is the system that you can see on the picture, and its main objective is to detect when fish are going to stop eating and when give a warning to the feed operator to stop the feed supply. In this sense, the main features of the system is that it is a passive acoustic system which integrates machine learning and deep learning algorithms, and it can be controlled via internet. The system is also valid for any species, and it is compatible with any type of feed. But the real question would be, how does it work, right? So yeah, the SICA is composed by two modules, the data logger and the control unit. The data logger is located within the SICA infrastructures, and the control unit should be located where the feeding control where the feeding process is being controlled, whereas it is a boat or an offshore platform. Either way, it's okay. Yeah, the data logger will acquire the data from a passive acoustic sensor, and will send this data to the control unit via a wireless communication device, and the control unit will apply these machine learning algorithms and will find out when the fish are going to stop eating, to give a warning to the fish operator. And I've made a quick video. So the SICA is collecting data, and the data logger will send it to the control unit until the control unit detects when fish have stopped eating, and the feed supply will stop. So in this sense, SICA should be an environmentally friendly system, since it implies feed waste reduction, a sustainable environment, and it is a non-invasive system for the species of the cages. To whom this system is targeted? Well, there might be different end users, as you can see in this table. For instance, Atlantic salmon farmers, by improving the efficiency in salmon feeding through the use of non-invasive, cost-efficient and accurate technology, or maybe technology producers because of the production of novel passive acoustic systems for offshore fish farm, or maybe agriculture researchers, since it has been proven to improve the knowledge on the amount of fish feed that is eaten in sea cages environments, and also it has proven to optimize fish feed diets based on measured and validated data. And finally, it could be interesting also for the agriculture marketing and lobbying groups, since it supports agriculture's promotion as a sustainable, dynamic sector, working towards global food security while decreasing the environmental impact. So, considering all of these benefits, they also applies to the economic aspect of the sector, since the SICA under the AQUAEXCEL2020 project has increased the knowledge about salmon behavior in offshore sea cages during the feeding process. It has also increased sustainability of offshore fish farms through a reduction of the environmental impact of the feeding process, and finally increase the competitiveness of the salmon farming sector through a reduction in feeding cost and waste. Right now, SICA is being validated with CBREM and CBAS in the Mediterranean seas under the framework of the European project DEMO Blue Smart Feed. With this project, we aim to have the system ready for commercialization by 2022. And in addition, as part of this AQUAEXCEL2020 programming, we have worked along with SINTEF ACE by validating the system with Atlantic salmon. And we plan to publish the results of this project by the end of this year or the beginning of the next one. And I don't know if I'm, my last slide is to say thank you to SINTEF ACE for collaborating with us during the project. And yes, I don't know if I have been really fast, but that would be all. Thank you, everyone. Feel free to ask anything.